There's a revolution happening right now, but it's not being fought on some distant battlefield. It's happening in basements, in community labs, and of course in universities. It's a biological revolution, and for the first time ever, it's putting the power to literally re-engineer life into the hands of just about anyone. So what on earth does that mean for us? Let's get into it. And this is the central question, right? This isn't some sci-fi movie plot. The tools to fundamentally rewrite the code of life, they're becoming cheaper, easier to use, and more accessible every single day. And that forces us to ask some really tough questions about what we're prepared for. So how did we even get to this point? Well, it's really being driven by two incredible parallel movements. On one side, you've got the formal academic world of synthetic biology. And on the other, you have this amazing grassroots movement called DIY bio. Now, even though they come from different places, they both share this radical core idea to make biology something that can be designed, built, and shared, kind of like open source software. The goal is to make it easy to engineer. Think of it as biology for the people. Okay, so let's break it down. Synthetic biology, that's the top-down approach. It's happening in big universities and major industry labs. DIY bio, which you might know as biohacking, is the complete opposite. It's the bottom-up, citizen science version happening in garages and community spaces. They're really two sides of the same coin, both pushing us towards a world where anyone can be a biologist. But, and this is a huge but, when you open up a field this powerful, you create this fundamental tension. On one side, there is incredible, world-changing promise. And on the other, there is the peril of some really catastrophic risks. I mean, the optimistic vision is just breathtaking. Just imagine for a second, engineering organisms to create totally clean energy, producing life-saving drugs for pennies on the dollar, building a truly sustainable green economy. This is the future science fiction has been promising us for decades. But with great power, you know the rest. When you democratize a technology this potent, you lose control. And the more people you have experimenting in less formal settings, the higher the chance that something goes horribly wrong, either by accident or, much scarier, by design. This opens the door to what experts call black swan events. And this is the real fear here. We're not talking about small, manageable problems. A black swan event is a single, completely unforeseen catastrophe that could have devastating global consequences. It's the thing you never see coming. So as you can imagine, a situation this high stakes has created a deeply polarized debate. The whole conversation has pretty much split into two warring camps, and you can sum them up with two really powerful analogies. The fear of creating a Frankenstein's monster versus the creative fun of building with Lego. So in one corner, you've got the activists. They're warning of a Frankenstein scenario, and they argue that we should hit the brakes, maybe even shut down any research with unknown outcomes before we create a monster we can't control. And in the other corner, you have the enthusiasts. They see bioengineering as harmless and creative, like playing with Legos or coding a new app. They champion a right to innovate and basically say, hey, trust us, the experts, we've got this. But here's the thing. That Lego or computer analogy from the enthusiasts, it's dangerously flawed. As this quote gets at, computer viruses are a pain for sure, but they can't kill you. Bioengineered ones absolutely can. The stakes are existentially, fundamentally different. Now you might be thinking, haven't we dealt with big scientific breakthroughs before? And yeah, we have, but the old rulebook is completely useless today. This just isn't 1975 anymore. See, back in 1975, you could get a handful of the world's top scientists in a room, and they could make a gentleman's agreement to self-regulate. That is just unimaginable today. With the internet spreading knowledge everywhere, totally new security threats, and a public that rightly demands a seat at the table, that old model of closed-door decision-making is totally obsolete. So what's really changed? Well, it's a dangerous cocktail, really. You've got a kind of moral arrogance from some researchers, this belief that any technical advance is automatically a good thing. You've got the complex post-9/11 security landscape. You've got global access to know-how and materials like never before. And on top of all that, governments are now laser-focused on preparing for those low-probability, high-impact events. It's a completely new ballgame. Okay, so the old rules don't work, and the current debate between stop everything and trust us is a total dead end. We need a new path forward, one that cuts through all the hype and the fear and gets real. This is the core of it. We need a third way. Shutting down this incredibly promising field isn't a real option, but blindly trusting a small group of experts to handle it all isn't either.
We have to find that difficult middle ground between prohibition and permission.
The proposed solution is an approach called human practices, and the idea is pretty brilliant. It's not about trying to prevent every bad thing from happening, and it's not about blind trust. It's about preparation. It's a vigilant, pragmatic way of looking at the real-world situation and getting ready for every possibility. So what does that actually look like in practice? Well, it means rigorously analyzing all the potential dangers. It means tracking what's actually happening in labs on the ground. It means wargaming different scenarios with everyone involved, from the scientists to the first responders. And maybe most importantly, it means training for emergencies before they happen. It's about being prepared, not just being hopeful. And that leaves us with one final, really critical question to think about. If the worst happens, if one of these black swan events occurs, who is actually to blame? Is it the person who created it, maybe even by accident? Or is it the experts and institutions who saw the risks but failed to prepare us for them? It's a question that shifts our whole focus from blame to responsibility, and it's one we all need to be asking.